Hello. So I'm Vincent Bailey. I'm a French citizen working from Norway. I've been doing JavaScript at Microsoft for 7 years. And today I'm going to talk to you about how we develop JavaScript in Microsoft. So I'll start by explaining a bit how we see developer productivity. Then we'll look into how we structure our JavaScript in Microsoft. Then we'll look through the different developer workflows we have. We'll see how we optimize these workflows. And then in the end, we'll see what is our end goal on the journey we are on. So to get started, let's have a look at how we look at productivity. So the most simple developer workflow is as follows. You go from an idea to implementing and releasing that idea. And then when this is done, you typically get some kind of feedback, and then you start all over again. And so if you follow the arrows, you see that this makes a loop or a circle. And so this concept of loop is a concept we use a lot for productivity. And we'll see why it's very useful to look at things this way. And so the very simple flow that I showed earlier, it had a big problem in that if I wouldn't get feedback before the next release. And for instance, like if we mess up something or there is a feature that is not as good as we thought we were, then we know only when it's released, and then it's out. Then all the reviews are bad. So we want to avoid that. And so to prevent this, we can introduce that step of prototyping, and then getting review from a small set of beta testers that will give feedback and allow to iterate over the implementation or the idea before we go spend a lot of time doing the implementation and the release. And so here again, we formed a small loop by having arrows going in circle. And so this is, in this case, what we've seen is we initially had a big loop, and then we changed the process to have a smaller loop. And that process of making smaller loop that allows to catch issues or validate ideas earlier is called shifting left. And so we'll see now how to apply that and how to not apply that. So we'll go through a quick small story. So last summer, I was in France, staying with my parents, and I was looking at my father typing a mail on his computer. And it went like this. So my father looks at his keyboard as he types, and then at the end of a sentence, he typed the period, and then he look up at the screen and look at the sentence. Okay, that's right. That's what I wanted to type. Or in that case, oh no, I made a typo. So when that happened, my father will press a certain amount of time the backspace key, one at a time. And I'm sitting there looking at this happening, and then when finally the typo was corrected, then he typed the rest of the sentence again. And so me, DevOps engineers, thinking of loop, I'm thinking, that's not very efficient. The loop that I'm seeing is like, the size of the loop is like a full sentence. What if we shifted things left and we made the loop a single word? Should I suggest to my father that he should just type a word, then look up, then validate that word, then type another word, then look up and validate that word, etc. Then he wouldn't have to delete so many characters, and but thinking about it, that will require to add a lot of eye movements back and forth between the screen and the keyboard. And most of the words he types don't have typos, so this will be a lot of wasted movements that gets the eyes very tired. So actually, this is an example where shifting left is not a good solution, because actually it will take more time overall than to do the way he did. And the proper way to shift left is to actually to learn to type without looking at the keyboard. So with that story, we see that shifting left the loops is a good way to optimize the developer productivity, but it should be applied when it makes sense, because it doesn't make sense all the time. So we need to make sure that the burden or the extra steps it adds actually remove more mistakes and save more time than it creates. Okay, so the third thing we're going to look regarding developer productivity is the concept of building and validation. So this is some piece of JavaScript code, and if we that just enumerate a list of cars, and if we run it, this is the output, and we see that there is a mistake in the program. We see that there's a typo here. But I actually need to run the program and see the bug to catch that issue. So in order to catch these issues earlier, we use TypeScript. And so this is the same program in TypeScript where you see in the editor here, this is the typo is highlighted in red, meaning like there is an issue. So you get that feedback that you made a mistake as you type. You don't need to go all the way to running your application and observing the behavior to realize that you made a mistake. So a lot of mistakes can be caught by the type system of TypeScript. And then when you have an issue, TypeScript also provides some useful messages to help you understand. So in this case, TypeScript understands that you made a typo, so suggests you how to fix it. Okay, so to go back to building and validation. So it's all and well, we code TypeScript code, but we are shipping front-end applications that are going to be executed in the web browser. And the web browser only understands JavaScript. It doesn't understand TypeScript. So we need to convert that code to JavaScript. So that process of converting the code that the developer writes to code that the browser will run is called building. And in parallel, we have the process of validation that the output of this process, it tells you that your code is doing what it's intended to do. So in this case, the validation produces an error, and when everything is fine, the validation say all is good. Okay, so now that we've seen the very high-level concepts that we deal with about productivity, we'll go over how we structure our JavaScript code in Microsoft. And the first level of granularity is the repository. So as a repository, we use Git. And so what a repository is basically just a folder with maybe some subfolders and some source code in there. And the difference between a Git repository and just a folder structure on disk is that this is versioned, which means you can change things, change the code, and if the change is not good, you can roll back to a previous version. And these changes and rollback, you can do it in an atomic fashion, which means if you have a change that spans several files on that repository, you can change all of them in one operation, and then if you need to roll them back in the future because there's a bug, then you can roll back all of them in one atomic operation. And then for the rest of this talk, to make my life easier, I will not say Git repositories, but I will just say repo. And they will be represented like that. Okay, so we have two extreme architectures in JavaScript on how to structure code in repository. We have the monorepo and we have the polyrepo. So monorepo, this is an architecture where 100% of the source code you write is in the same Git repository. And the polyrepo world is a world where you split your code in many different small repos. And both have their advantage and so monorepos, they are very good in that the workflow is very simple. You can do the end-to-end workflow in atomic steps. And yeah, the workflows are very simple. Whereas polyrepos, you have to go through multiple steps to deploy your and to implement your features. So you lose that atomic change benefit. The problem with monorepos is that as they become larger and larger, the tooling, if it's not optimized for that scale, tends to slow down quite dramatically, making up, in the end, the developers not too productive. The polyrepos, it's also a complicated setup because every repos, even though initially they are the same architecture, over time they may drift from each other, so they may have different workflows associated with each, and it becomes very cumbersome for developers to know, oh, in that repo you need to run that particular command, but in that other repo it's a different command you need to run. So that's an issue with the polyrepos. Yeah, so how in Microsoft we try to be pragmatic and use the right level where it makes sense. So we have a few repos, and so we have like OneDrive. The code for OneDrive is in one repo. The code for Microsoft Teams is in one repo. The code for Outlook is in one repo. A Git repository, I explained this in the slide earlier. So yeah, a repo is a short for Git repository. So we have this big applications repositories, and then this big application, they have components that are shared. There is pieces of code that are running in Teams and also in Outlook. For example, this is called the Live Personal Card, this component you see here. And even though it is it has a different display based on the application it appears in, there is a lot of code shared in common between these two components. And so to prevent this code to have to be developed twice and to make sure they are consistent, we also have some repository which where the shared components are being hosted so that all the other repos can use them, and there is only one implementation of these shared components. So we have some like the most basic components, UI components. They are open source on GitHub in the repo called Fluent UI. And we have also some higher level components like the one I just showed that are in a private repo. Okay, so the repository was the first layer of organization of the code. And then now we'll look at how the code is organized in a repo. So in a repo, the code is split in packages. So a package is basically like a repo, is a folder with source code in it, except there are several packages in one repo. And every package also has a special file called a manifest that is called package.json. And that contains the name for that package and also contains the name of the dependencies it has on other packages. So we'll see now what this looks like. So this is on GitHub, this is an open source package. And so you see on the left, there are all the files in this repository. So this is the source code. And on the right, you see this manifest file. So you see that it has a name, in that case it's Webpack, and it has also a list of dependencies, which are themselves packages with these names that are defined somewhere else. So to see in code how this is used, so in that case, I have like one package with two different files, and one file is using the code imported from another file. So the function is defined in one file, imported in the other, and used. And so if we want to split this in two different packages, what we'll do is we'll create somewhere else another package which has its own name, and we just implement the function we want to share. And then in our initial package, we just declare that we take a dependency on that package, and then we import it, but this time not with the relative path, but just with its name. And so this way, we don't have to care about where is the implementation of this greet function. We just declare that we depend on it, and that's all we need to know. And so this concept of packages having declared dependencies on one another, that leads to a dependency graph. So since there is several packages in a repo and there is dependencies between these packages, we can represent this as a graph like so. Okay, so now we'll go into how the workflows look like. So the first workflow is to set up. So when I start working, the first thing I need to do is to get the source code, the latest. Then I need to install all the dependencies of that source code, and that could be like global dependencies like Node.js, or that could be like dependencies that are just small packages that are hosted on GitHub, for instance. Then we need to build. So build, we talked about it earlier. This is converting the TypeScript code to JavaScript. And then at that point, we are ready to code and to test what we are doing. Okay, then another workflow is the workflow within a single repo. So as we see, we set up the environment, as we've seen before. Then we implement our component or our code. And then we validate that the code does what we want it to do. If it doesn't, then we go back to implementation and we iterate until the code does exactly what we want to do. And then when everything is fine, we publish a new version of that code. So here, this is the loop in that scenario. And the loop is, in that scenario, it's about 1 hour, give or take. And now we'll look at the more complicated loop when we have to develop code that is spread across different repos. So we have on the left the shared components repo, and on the right the Outlook repo. So you need to set up your environment for the shared component repo. You implement your component. Then when you're done, you need to publish it, so it can be consumed in the other repo, which you also need to set up. And after that, you can import your new component and use it. And then you can validate that it does what you want. And if it doesn't do what you want, then you go back to step 2 and iterate from that. So that's a big loop, as you see here. And it can take anywhere from 2 to 12 hours to do that. And so that's not good for productivity. So we try to detect issues earlier and shift loop left. So let's see what that looks like when we create smaller loops. So we, as before, we implement, but here we introduce some validation. So before publishing, we validate that it works as intended, and of course we cannot validate fully that it works as intended in Outlook because we don't have Outlook there, but we can already test a lot. And we iterate here, and only when we are confident, then we publish and we do the rest. And then the number of time we will have to go through this big loop will be much less, and most of the time it's 0. Most of the time the validation we've done early is good enough to catch every issue. So in that case, that loop is about an hour. But this is still very long, so we can try to do even smaller loops by introducing different validation earlier. So we have IntelliSense, which is in VS Code, the text editor. When you type, you have these errors that shows up as you type, like we've seen before. That feature is called IntelliSense, and that gives you feedback within seconds if you made a typo. And with TypeScript, you can get notified by quite a few different types of issues within seconds. And then when IntelliSense tells you your code looks good, then you can run some unit tests or some component tests. And then if they are not good, you iterate. And then when you're confident with that, then you can go with the full validation, and we'll see later what that means. And then again, you iterate, and then in the end, you can publish your component. So here we have that component testing loop that is maximum 1 minute. And then we have that small IntelliSense loop, like that is just seconds. And so this is an example on how we create a lot of small loops. All right. So how do we optimize all these loops to improve productivity? So we're running out of time, so I'll go quick over this one. We use trunk-based development, or also called GitHub flow. And this is also to reduce the iteration before we can catch, the time before we can catch issues. We use code spaces, which is, I think, the most productive or the best productivity tool we use. So code spaces, it's basically a virtual machine running in the cloud. So all your code that you're working on is in the cloud, but you code it in Visual Studio Code that is installed locally on your laptop or your machine. And so so with that, it's a virtual machine, so it's set up already. You can just create a new one, and within 1 minute, you get a new environment ready to work. It runs in the cloud, which means it runs on the most adapted hardware. For instance, if you don't have the latest hardware, or you have a small laptop or whatever, you still, the code runs in the cloud, which is very powerful VM. So you can still do very expensive validations without having big chunky laptops or using your battery, having the fan spinnings all the time. Since this is running, the UI is local, you have no latency when you type. So this feels like you're coding locally. It's brilliant for multitasking because you can have several at the same time, open at the same time, and if you working in one machine and then you in the office and then you go back home and you want to keep working at home, then you can pick up where you were from a different computer. You don't need to have different setup. And also you can do that from almost any device. There is no, as long as your device can render a website and has the screen big enough, then you can code with code space with it. Okay, the next optimization we're using for productivity is GitHub Copilot. So GitHub Copilot is based on AI and large language models that predicts the code that you're about to type, and based on all the data GitHub has on code that has already been written. And so in that example, you just write the name of the function, and then you have in gray Copilot suggesting you some code, and if this is what you intend to code, then you just type space, and that's done. So that's a huge productivity boost as well. So I said that we'll come back to the full validation. So how do we validate that the code works? And there is many different ways to validate, because some kind of bugs are better caught with some type of validation and some other bugs with some other types. So we have, as we've seen, IntelliSense, we have the unit tests, TypeScript checking, we also have the component tests, we have end-to-end tests that run some automation that will like click around and take some screenshots and some videos to see how the application behaves. We have automation that detects how your code affect the performance of your app. We have linting and so forth. Okay. And then we'll see how all that validation is very expensive or is very compute intensive, and it's all run in a cloud. So you just need to submit your change as it's called a pull request. When your code is ready to go, you just submit it, and then it triggers a process that will validate your code against all this validation we've seen. And while this happens, then you can either stop working and go home and come back the next day, or you can do some code review or start working on some other tasks. And this means that because the cloud is doing all the full validation, you never need to worry that you're missing a step manually. So manually, you can only focus on validating what you think is likely to break with your code change. And we need to go quickly over this one. So this is scoping and caching. So we've seen earlier that within a repo, we can represent all the code in a package dependency graph. And that is very advantageous when it comes to optimization. Because for example, if I'm developing, if I'm coding some change in the package called people picker, and I want to manually validate that it behaves as I want in that package called Teams test app, then on my locally on my machine or on my code space, I only need to build this set of packages, and I can totally ignore the ones that are unrelated to, and I can ignore them because I know that the cloud validation will take care of validating everything else that I may have missed. And so how the cloud validation will work in that case is that since I have a change to that people picker package, I know that I only need to validate the packages that can be broken from your change. So I know that only the ones that are in green now could possibly be impacted by your change, so we only need to validate these ones. And then to be able to validate, we need to build some other packages that couldn't have been changed, but we still need to build them to be able to run the validation. And there is still some packages that we don't need to do anything about because they are totally unrelated to your change. And so we have several different scripts for building and for validation. That was an oversimplification. When I say we do build and validation, there is a lot of different type of validation and type of building. And so if we put all of them together in the dependency graph, that looks like this. And so we can build like a dependency tree between these between these tasks. And so the cloud validation will schedule this in the most optimal way, spreading the load on different machines and then parallelizing the work. And for all the packages that you need the build artifacts from these packages, but they haven't changed by your code, then you can just retrieve the build artifacts from your cache, which will speed up the build a lot. So this is caching. And so just to finish, where it is our North Star is that with all these optimizations, we'll get to a place where we would be able to have all the JavaScript code in Microsoft in a single repository, but all the optimization makes still the flow smooth enough and fast enough that we can have a single monorepo and be productive, which will simplify a lot the number of steps and the number of loops that we have to deal with. Thank you very much.